Hello, everyone. Hello, Kevin. Hello, Jose Luis. Welcome to the first .NET and AI community standard of the year. So I don't know how long we do this, but Happy New Year to everyone. Hey, Bruno here, Bruno from the Cloud Advocate .NET team, and super happy because we have Kevin and Jose Luis today. So can you introduce yourself super quickly, Kevin? Please.
Yes. Okay. Thank you, Bruno, for inviting me. I'm Kévin Beaugrand. I'm a technical architect working at CGI in France, at Clermont-Ferrand, which is in the middle of France.
Cool. And Jose Luis?
Yeah, hello everybody. I'm AI passionate. I'm a Microsoft MVP on AI, also a LinkedIn course creator and passionate on open source AI, everything Kevin knows. Kevin, sorry, I pronounce it wrong every single time. So here I am, happy to be here, and Happy New Year.
Yes, Happy New Year to everyone. And hey, today we are going to talk about RAG, which is something that we talk a lot. I am also super proud because this is the bragging time. 2 years, it's been 2 years, we run 2 editions of a hackathon for RAG globally at Microsoft. This is a full month of hackathon where we have a lot of people doing RAG, not attached to any framework, language, product, or anything. It's just doing RAG. And fun fact there, even if when you think about AI, Python is the main language for a lot of people, the two main winners from last year and 2 years ago were solutions created in .NET. So I know this may tickle a couple of people, but I am super happy that we have very amazing people doing .NET stuff with AI. And today we have this twist about RAG. When I read your stuff the first time in LinkedIn from Jose Luis and Kevin, really blow my mind. I like it. So we are going to talk about this. But if you're okay, Kevin and Jose Luis, I am going to share your screen and we can start.
Yeah.
Perfect.
Okay.
And by the way, in the meantime, I am the worst host ever. I know. We are going to take a look at the chat. So in example, feel free to say hi. If you have questions, we have the questions there. Let us know what do you think and more. And hey, super happy to be here. We lost Jose Luis. Check the links if you want to know more. But I am going to share Kevin's screen right now.
Okay, good. Can you see my screen?
Yes, there it is. Perfect.
Yeah, good. So that's me, that's your host for today, but that's not important. What I'm talking about today is about how to use RAG. Maybe you know that, but to clearly understand that, when we are talking about how to use LLM into enterprise, we are focusing about how to explain the data, the private data to the LLM to get accurate answer. And I am really obsessed about the accuracy of LLMs, since we are using RAG or other techniques and so on. So to just clarify what is RAG for people who don't know that, RAG is a technical that we use in order to provide some chatbots, for example, about private data. So we use our documents, our private documents, to chunk the documents into some parts and so on. And we vectorize the chunks. We create some vectors about knowledge inside the chunks. And those chunks are stored into a database. And when we are using a chatbot, we ask to the LLM to answer the question with those data. The first part we use is to create a new vector about the question and search into the database the similar vectors that have the same kind of sense, the same kind of meanings of the question. Those chunks, those parts, are used to tell the LLM what is the knowledge inside the database, the question made by the user, and we ask the LLM to respond to the user for that. Okay, that's pretty clear, pretty simple, in fact. But to do that, we have many technicals. Some technicals are part of the chunking strategy. We have also some other kind of technicals that are like graph RAG, where we use the knowledge graph into the Retrieval-Augmented Generation framework to create a representation of the data within specific relationship with nodes and edge and so on. And this part is quite difficult to create, because to create a graph for an enterprise, you have to create also the ontology and to link the knowledge for the document to these nodes and edge. We have also another kind of techniques, which is the CAG, Cache Augmented Generation, which you can use in order to have a specific question and answers stored into a cache and directly provided to the LLM to have a low latency response. But here we will talk about the challenges within the RAG. You have some challenges for the knowledge, because the knowledge is not always clear in our documentation or our documents. You might have some scattered information where the information is not directly present into your document, so you have to reason on that. You have also some other challenges like noise, because you have many informations and you provide many information to the LLM, and you will have some issue with that, because it can appear lost in the middle during the LLM process. So the context loss, and it is also difficult to scale that. Those limitations can affect the accuracy, and as I said just before, I'm obsessed about the accuracy of the generated response. So this process I will show you is a process that is directly derived from the cognitive research. The objective of that is...
One second, Kevin, just to double check if we understand, and probably if someone in the audience is new to RAG. The whole idea of RAG is one of the techniques that we have, that when we want to take advantage of the amazing large language models, you can chat with the large language model and you are going to have the feeling that you are talking with the person, because they are very good generating text and completions and more, but they have been trained on a set of data, so they know what they know. I'm going to quote that. If you want to add more info to the chat so you can talk about other topics, there are different techniques. One is RAG. But as you mentioned, we usually, what we do, and we see this in a couple of episodes, a couple of times, we usually have a vector store like PyCon, Quadrant, Azure AI Search, and more. And the way that we do this is in the very raw and simplest way. We pick up some document with data. We chunk the document, we split the document in different chunks, small chunks. We generate embeddings, which are basically vectors, numeric vectors that represent that data. We store there, and then when we want to ask a question, we ask the question, which is basically transform the question also on embeddings, and we use some mathematics to compare the vectors, and when with the closest vector, that's probably going to be our answer.
Yeah, it's a similarity matching.
Yes,
it's pure mathematics in a multidimensional space.
Yes, but what I like is what you mentioned there, that approach works, is great, it's fine, literally works very well, but we have issues like the noise that you mentioned there, and a couple of others. So that's where you get to this point. And hey, I really want to know more. So sorry, I was double checking.
I would like to highlight the two challenges here, and I hope that Kévin and you, Bruno, will agree with me. Aside from all the evaluation methods, usually the problems are two. One is that the chunks some chunks have parts which are not related, and we can retrieve them. So what we retrieve is not properly. So there's usually something called chunking strategies, right? Which try to make a chunk as big as the context is together and has a meaning together, right? Like take one chapter of a book or the chapter and a half, which are talking, taking a specific topic. This is one of the techniques. And the other is how we retrieve the information, right? And for this, there are many techniques. Kévin mentioned one of them, I think. There is also ranking, re-ranking. There is this graph rack that he mentioned. There is another one, which is a requery, which is another paper. I think it's mentioned on the Struct RAG, but there are many ways. And today, I think this Struct RAG is at the moment the cream of the cream, one of the best in the leading, not only in performance, in everything that makes a query good as a response,
Hey,
but
no
also in
pressure for
performance.
Kévin.
Yes. Okay. But I
Sorry,
think it's
Kévin.
super exciting.
I was trying to minimize, hey, this is going to be fun. We are going to learn. And Jose Luis just said that, hey, this is the best of the best. So everything will happen. No pressure for you.
Well, I let Kevin show something that he will, but I mean, I was digging in this weekend a bit more deeper and bothering Kevin a bit, but I let you.
Yeah, no problem. So please, Kévin,
no problem.
back to you.
The Struct RAG is about how to create a process into reasoning, into perform a precise reasoning into the data. To do that, like I mentioned, it is a research that use the cognitive research process human use to understand the documents and to provide a precise answer. The first step we use into the StructRAG is about how to identify the optimal structure of the data we need to have in order to answer the user. For example, when we are talking about what are the key precedents, legal principle established in case in similar client regarding the breach contract, we are asking the LLM to classify which kind of data is relevant to provide a good answer. And to do that, we can use some chunks, the normal RAG, and we can also specify that to do that, we need a graph representation of information, or a catalog representation, or also a table representation. And for this kind of question, in fact, the good format to have a good answer is a table. When we have this step, we know that our data, our chunks, are not represented into a table, in fact, because it is not always represented as the user query is made. So we reconstruct, sorry for my English, the knowledge based on the question. So we have the question, we have the documents that are part of the information that have the knowledge, in fact, and we ask the LLM to reconstruct a structured knowledge based on this kind of representation, because we need that. And we have also a knowledge description. And once we have this kind of data, this kind of structured data, we do a reasoning. So we decompose the complex query into subqueries, and we ask the LLM model to answer each subqueries before getting a final answer. And this final answer is then given to the user. Around that, we use also some metrics and so on in order to understand what is going on into this process. Clear for that? Maybe we can do a special diving into the code. Yeah?
No. I was going to say yes, super cool, and get the point. And yes, it's ABC, super straightforward. So we can. It makes sense to have it there. And the interesting part, what we are going to talk a little more, is that we are going to also show how we can implement this. This is the nice part, because you pick up the kernel memory base that we have in semantic kernel, and because it's super extensible, correct me if I am wrong, there is an implementation of this, of how you can do this and write. And I see, yes, I see a couple of comments there. Bliss is, some old RAG people are knocking there. They want to come here, but no, they are not going to come in. No problems there. This is the live event. Yes, I don't know. Before we start to see a couple of code and more, I want to tackle one of the questions that we have here that it's more generic. It's not related to Struct RAG, but is if we can use nested JSON data as data source for RAG. I would say yes. I mean, literally, one of the samples that we have in the Azure samples is feeding a vector database with JSONs, and it goes there. It's a very basic RAG technique, but JSON as a data is fine. I don't know if Fizzle can share something else about your scenario. There may be some tricky part that I can't. I don't understand that what you are meaning there. I don't know. Kevin, Jose Luis, do you want to add something in using JSON data as data source for RAG?
Not me.
No, I think it is clear, but some JSON data is not a semantic data. In fact, when we are using LLM model to answer a question, we need some structured data, some unstructured data for us, but some semantic data. That's
text.
The kind of data which is used. Sorry, Jose?
Usually text or even code, I would say. Code also works because it's unstable, right? But JSON, I agree completely with Kévin on this. Yes, I think aside from the brilliant presentation, I think it's a great moment to share maybe the link of the paper, which if anybody wants to curious on it.
So everything is here. If you take a look at this link, we are adding all of the resources there. I think I added everything. I double check that we have. I'm going to also share this in the check. And also we have here, I'm sorry, I'm going to butcher your name, Porox, or I literally can't read names. So sorry about that. But they found the repository yesterday. Great work, Kevin. So appreciate the nice feedback. And in the meantime, I have your code ready to show here, and I'm a code person. So do you want me to share the screen, Kevin, and we can start to take a look at the code?
Get it done, but I would say that I love the code. It's super integrated with semantic memory, right? The kernel memory, and to me, it's brilliant. It shows that, Kevin, you really know kernel memory pretty well. So I really love how you extended that. So it's
thank you.
If anybody is here, I recommend go and try it. It's free, it's open source, and it works.
Yes,
of course,
a couple of things. Sorry, I'm picky here. Can you click on hide in the toolbar in the bottom, so you hide the toolbar there?
Yeah.
And the other, can you zoom a little, control, and perfect. I'm sorry, I'm super picky, but I like to give the people reading here the chance to have more. And I am sharing the links and everything in the collection that we have here for this.
Good. Thank you. So you introduced kernel memory, Jose, just before, but for some people who don't know what is the kernel memory. Kernel memory is a framework made by Microsoft and produced by Microsoft in open source in order to provide a simple pipeline for creating a vector database and also answering to questions from a vector database. During this pipeline, you have many steps you can follow, like data extraction, data chunking, and so on. And as also Jose mentioned, I extended the kernel memory in order to provide a specific search client, because you can also have a specific search client. And for that search client, I use the StructRAG methodology, which is also open source because it is made by a Chinese team specialized in cognitive research. And I use that to create a simple way to use the StructRAG methodology directly. To do that, we saw some steps we follow to create the StructRAG, and some steps use semantic instructions to do that. For example, you have the first step, which is the routing. So routing is about classify which kind of data we need to have in order to provide a good answer with some examples. We have also another way, which is, for example, the construct table, where we have instruction about formatting a good table to provide a good answer. Okay, so that's this kind of instruction we gave to the LLM to create these steps. in my sample, you will have two parts, which is the StructRAG framework directly integrated into the kernel memory, but you have also a sample of data. Let me talk about this sample. This sample is made by GPT because I invented a scenario. And for that scenario, I worked with a fictive tech corporation, and I use StructRAG to provide good answers about a comparison between the revenue of this company and the investment into AI. And I gave him also some other information for competitors, for example. And the question I will ask to the LLM is to provide the most competitive company in artificial intelligence services. Okay, so the goal for the LLM is to compare the revenue regarding the research and development investment, and to give which company is the most effective, is the most yes, I lose my words. Sorry, which company is the most yes, effective, yes, efficient, sorry. Okay, and for that, I use Olema, and I use also some small models because I don't want to use GPT-4o because it is expensive, or it is also a reasoning model. So it is important to explain that you have this kind of working process precisely into some kind of models like O1. O1 is a reasoning model, specialized reasoning models. But for this sample, I will work with Mixtral, which is a French model. This model I didn't fine-tune. And the other model I use is the embedding model, Nomic Embed, for this sample. What I can show you
before we move forward, and this is interesting, and we probably want to add this later to the repo. You are running this, but this is not tied to be just using big GPT-4o models in the cloud. Yeah. You are literally running this with the local model, Mixtral. We love Mixtral. They are super fun, and we also create amazing models. And I can't remember which one do you have, Mini LM. I can't remember. I didn't take a look at the one that you have there, or it was the Nomic for the embeddings. So you are running this locally. So this is also something that I think is important. Once again, sorry for repeating myself, not just for big models. You can run this approach. This StructRAG will work with any RAG approach, and the RAG approach usually doesn't depend on big models, depend on just models. So hey, I like that you have this like this here. And I also see that you are adding details here in terms of the token, the SIF, the top K, and more. We can talk about this later. Yes, and I love, sorry about that. Jose Luis knows me. I love local models. They are basically, I don't know what's happening with Olema today.
Just read the chat.
Yes, I love local models. They are running your machine. And hey, we even released Pi4 a couple of weeks ago. I can't remember when, which is a super popular one, a super powerful one, and there are more and more. We talk a lot about local models here and there, and what I love about semantic kernel is basically makes easy as can be to switch between big cloud deployments, local cloud deployments, or whatever you want to use. So yes, all in for local models. So sorry about this. Team is asking for a link to the source. I am going to add it one more time. You can find everything here in this link, aka.ms, with the Net AI episode 17. So you have the paper, the GitHub repo, a couple of documents, and more. This is part of also of the session description. If you want to take a look at what we have there. So let me go back. And thanks on Jose Luis to share this. So we can go here. And sorry, Kevin. This is how we work. We interrupt the audience and the speaker a lot.
No problem. It's a live streaming. No problem for that. Yes, as you mentioned, we use kernel memory to connect to the Olema process. So we have here using the local models To be clear, it is a model hosted in Azure, but it is in a VM, a virtual machine that I provided to under the hood. And we have the possibility to configure the search client. As I mentioned, you can also modify some other kind of settings, like when you don't have the answer, no answer. For example, you have also the possibility to modify some prompts or some settings into the prompts or the prompts parameters, like temperature and so on. But I don't want to do that now because it is not relevant for my use case. I have also the possibility to modify the text partitioning option. It is the chunking part, in fact. And I also have the possibility to specify where I want to store my vectors. Here, I'm using Quadrant. Quadrant is stored locally into my PC, into my personal computer here. And in my sample, I import some documents. I have here, it is some documents I showed you just before, this one, which are relevant because it is our knowledge. And I will ask one simple question. The question is about comparing investment and revenues to tell what is the most efficient company in artificial intelligence services among all competitors. I have 3 competitors, in fact. I will use the standard RAG strategy, which is about getting the most relevant chunks and providing the good answer to do that. And I will use my implementation about StructRAG. And my implementation is quite clear because I have here the possibility to specify a custom search client, which is my search client. I will deep dive into him just after. And once I've had that, I can compare manually the answer provided by the kernel memory. We have just the search, which is different because the memory pipeline with the vector stored and so on are really the same because I use the same data just after that. I imported only once the data and use that into the 2 search clients, right? So let me show you what kind of answer I can have with the first RAG, the standard RAG strategy. I guess you will have that. Okay, so it is quite long because I don't know if the model is well loaded into the ULEMA, but we will have that. Yeah, right. So as you can see here, I have a response made by the standard RAG, which is Innovatis Limited, which has the best revenues and so on. And it appears to be the most efficient among the listed companies. This answer is not good. Let me show you why. Because if I take Innovatis, we can see that the revenues are maybe the most important within these companies, but the investment is also the most important. So if you take a look at that, you can see that the ratio between the investment and revenues are not the better for him. The best is for fictive tech, in fact. So the model did not have the possibility to reason on that and did not have the possibility to understand that we have many information spread into our documents, into our chunk, and make some relation between this kind of information. That's why.
So, Kévin.
Yeah.
So it is akin, this StructRAG, to a kind of an agentic system, right?
Yes, it is a simple or a generic way of creating an agent. Because it can reason generally. It is not a specialized agent. Yeah?
Yeah, pretty cool.
Okay. So now we know that the first answer is not good. So if we can go to the StructRAG, maybe I can be sure that I have the breakpoints. Yeah. I will let the StructRAG working. So the first step, as I mentioned just before, is about classify which kind of information we should have. Okay. This, for that, the model determines that the good way to answer is to route a table, to get a table information. So this is the first step, classify which kind of information we need. Then we have a structurizer, which is in charge to create a structured information about which the knowledge present into our database. For this one, we'll use the construct table prompt here, and we will have an instruction, which is this one. We have this query, okay, and you have to create a table from our data and provide good information to get the answer. And this kind of information we can have is that we have a table here which explain which are the investments made by each companies, which are the revenues made by each companies, and also it has calculated the ratio between the revenues and the investment. And here you can see normally fictive tech is the most effective because we have the better ratio. That is very interesting because we now have the possibility to get into the other steps and get the subqueries made by the LLM. Yeah, and this subqueries are this one. Yes, identify the company with the highest efficiency regarding the data we have. And then we have the sub-knowledge, which is the answer of each subqueries. For here, we have only one subqueries, which is this one. Fictive tech has the highest efficiency. Yeah, that's good. And now we can ask the model to create the final answer. And the final answer should be normally the good one. Yes, among all competitors, fictive tech is the most efficient company. Yeah. Yeah, that's cool for the demo because I show that the StructRAG is able to force the model to reason about data because we have the good structure of data to provide him. Let me show you some other information about, I created some benchmark about the StructRAG strategy in how some other kind of data. And I used RAGAS. I don't know if you know RAGAS, but it is a Python framework to evaluate some response about the LLM regarding the RAG strategy. Here, I didn't use directly RAGAS because I created a specialized packages, which is kernel memory.evaluations, which provides the same kind of evaluation with the same prompts. And I have some measures about the correctness and the similarity within the answer, the expected answer. What is important here is we can really improve the quality of the accuracy of the answers, but it is also interesting to see that we increase also the cost and we decrease the performance of our RAG. We can increase approximately to 5 times the cost of the solutions because we need more information and we have many steps to follow to have the answer. That's why we increase the cost. And the latency is also because we have many steps to follow and many calls to the LLM. So it's about thinking about which is the good cursor with the performance or the cost we have to we need for our use case.
One thing to add, if I can,
Yes, please go.
is in the paper there is a performance comparison, right? And a general score, which is the sum of these different evaluation methods that, by the way, Kévin also created them in his kernel memory evaluations, which is also on the resources shared. But in the paper, also in an article which I did, I summarized them. But what Kévin mentioned, that the performance is a bit bigger, that's only compared to the normal RAG, which is 2 steps, which is retrieve and generation. But if you compare that with RQ RAG, which has basically a query, or you compare that to graph RAG, it's more or less the same as RQ RAG, but it's doing a lot more and it's a lot more performant. And graph RAG is terrible. So it can take like, times of order of magnitude, like 20 times more than RQ RAG. So it's super, super slow because it needs to build the nodes and the graphs and everything. But the StructRAG, it's super, super fast. And also it, as you can see, it outperforms the normal RAG and also outperforms RQ RAG and graph RAG, which I think is at the moment one of the top techniques.
Yeah. I think also what is important to say about StructRAG is that we have this kind of performance because we force the model to reason on our data. It is really relevant when we are using small models, because if you use GPT-4o, for example, you can provide him all your documents because he have a good size of context capabilities, and you can ask him to answer the question. It will directly reason on your data. So StructRAG is not relevant for this kind of model. It is really relevant when you have a small model or model that has not this kind of capabilities, when you are running on Edge, for example, directly, or when you are using a really open source or small model you want to use directly on your PC.
Yes, and a couple of things to complete all of this. So first, let me share my screen. We released not so long ago, but not this one. This one. We released not so long ago. This tutorial is part of the resources where you can see how you can evaluate an LLM. So this is a full learn content where you can see that you can evaluate questions, and it's a console application, but you can basically build everything, and this is all here in the repo where we have tons of AI samples, but this is a way that you can evaluate, one of the ways that you can evaluate a large language model with .NET. The whole idea of this is that if you are going to use a small model, like Kévin was mentioning, like a Phi-3 in example, or a Mistral, or any other model locally, and you want to see how it works with the specific prompts, because those prompts work well with a bigger model, but you want to see how they work here, hey, this is an approach that you can take. And as I said, this is this is a nice way to learn how we can evaluate model, because when we work with this, we don't have anymore the standard F1 or accuracy. We use different scores here. So if you want to do this, the same that Kévin showed, but in .NET, take a look at the link. It's part of the resources, and you can see a full .NET implementation of this. That said, there is a huge and super cool in the AI toolkit right now. You have, if you install the AI toolkit in Visual Studio Code, for free, AI toolkit for free, you can run evaluations on models that you have, and you can, as you can see here, I'm all about having my models locally. Hi-Fi 3.5, Llama, of of course, GPT-4o in the cloud, but everything else is local, and you can evaluate data sets here with your models. So couple of different options that you have if you want to evaluate your models. And the third thing that I want to share is, yes, you mentioned about that the approach that you have here is something that is very popular right now, which is reasoning. You make your model think twice about this. And this is a door that OpenAI opened last September, I think, when they presented O1. O1 Mini, and now they have O3, which seems to be the craziest and most amazing model ever. But fun facts there. You can also use models like Marco O1, QWQ, there is a new one I can't remember here. You can use them also to ask them to basically solve problems and do some reasoning. This is a repo. I'm going to add it into the resources. That is not an official one. This is one that I created, which is literally a Blazor application where I ask questions like solve 2 plus 3. And hey, every model works great. But when you start to say something like an example, which number is bigger, 9.9 or 9.11? That question tricks a lot of models, because somehow 11 is bigger than 9, and because we don't have more numbers there, it gets tricky. So it's nice to see how Llama, QWQ, Marco O1, or even the O1 model, because we can test O1 model. This use GitHub models to use the other models, give you a sense of what you can do. So connecting the dots here and there, we can get the result, we can get the approach and make the model think a little more. I think it's something that using different techniques, we are going to see a lot in 2025. So not even close of what you were showing. It's not about the StructRAG, but working with models that we challenge them to reason a little more is something that is going to be great. And as you mentioned, it makes also a lot of sense when you don't have hundreds of thousands of tokens in context, like when you have GPT-4o or whatever other models, the big one models. I know that, in example, not in the Microsoft world, Gemini is huge, freaking huge. So make the model reason is a good technique to do this. There's a good question here about, not this one, but hey, 5.4 is very good for the site. Yes, based on, and again, you need to be careful with the benchmarks and more, but it seems that right now, and I have 5.4 open somewhere here, I need to double check. 5.4 gets a very, very good quality level in terms of responses or the size of the models. They compare 5.4, sorry, it's a tongue twister for me, with other big models, and it's literally half of the size. And we have another one, which is streaming. People love streaming when we are working with models, and when we are doing the chat stream, things are more. I don't know. Yeah. I would say. I don't know. Kevin, Jose Luis, thoughts? Yeah. I have my own idea here, but I want to tell you.
That's a good question, because streaming the response means that you want to stream the tokens provided by the LLM. But as we saw, you have many steps during the pipeline, the StructRAG, and if you want to stream, you can only stream the latest responses, the final answer, in fact. So you can stream that if you want, but you cannot stream each steps for the process, because you need the end of each step to go further. But exactly. the kernel memory provides a way to stream the response.
Yeah, the kernel memory, what you retrieve from the vector database, will never reach the user.
Sorry, it blew my mind. I didn't know that kernel memory, you can stream with kernel memory. That's amazing. That's super cool.
Sorry, it is in implementation phase, so maybe.
Oh, perfect. Yes. I'm catching up with a lot of stuff, so I was thinking no, but hey, if it is there, it will be in the future. So I hide the comment. Sorry.
They are doing now, I think.
maybe now it's experimental and it's going to be final soon. And hey, sorry, Jose Luis. Yes, you're going to say
No,
something.
but my thoughts here, does this make sense? Because in what business scenario will you need to stream the result? Because what you want is a model to consume the results of the RAG to respond to the query. So what you want to stream is the response to that query, right?
Yes, but I'm guessing that stream, and this is my point of view, stream is more about user experience. We
Yes.
like to give the user the sense that you are talking, so you start to see the tokens completion like you are listening something instead of boom, you have here 5 paragraph of response. So hey, if you want to give that your user that sense, get all of the response and show chunk by chunk implement something like this. Trick the user. If you are going for the user experience, and by the way, there are people who knows a lot about this, and the streaming technique, as Kévin mentioned, is because initially the models are basically completing the next token, so we can get the next token while they are talking while they are completing, but it gives you the sense that you are talking with the model. So kudos to that implementation. That said, it will be cool if we have that feature, but yes, probably depending on the scenario, you can wait a little more to do these kind of things. You don't need to have streaming everywhere. The user can wait a couple of seconds and have this. We have another good question here about probably is kind of the best scenarios. You mentioned a little about this. You mentioned about this make work great when you have small models and more, but if you have to sync kind of a specific task, a specific demo, do you have anything in mind about where to suggest to use a StructRAG?
That's a good question. On which task can StructRAG?
I think it's mostly asking what the router can do, right? Because basically it's deciding the best tool for the task. So either it's stable, which is what you show us, but it can be a structure or hierarchy if the information follows a hierarchy, or it can use kind of a similar approach as GraphRAG. Sorry?
Yes, you have also the possibility to create an algorithm for that, which is which steps I have to follow, which required step I have to follow to provide a good answer or to fulfill an action for the user. And the StructRAG can help to create a comprehensive algorithm for that. Is it another way to use that?
So I think on all these cases it excels because it's quite performant on all of them. So in general, it's kind of outperforming all the ones. I think there's on the paper, which was shared on the resources before, there are some statistics that show these exactly on the different scenarios. Either the data and the question is based for a table, either it's for hierarchy, or as Kévin mentioned, algorithm or graph. So I think in all these cases it's pretty good. Also, one thing to add is maybe it's something that we were talking on the weekend because I was playing a bit with the repo and adding some PRs on Kévin's code, which, as I mentioned, is brilliant. These could be even further enhanced by adding some agentic loop, right?
Yes.
So that at the moment is pretty good. So it brings the accuracy up to 90%, which usually in normal RAG scenarios is about between 50 and 60%. So I think it makes it usable for business, which is a big thing to say.
Yes, and hey, Sarosh went back to the original question, is that, and it makes sense, you are streaming your response, but yes, usually the annotations or the quotations or the citations or whatever, when you have the links, come at the end. So yes, the streaming have that chance, but that challenge, but it's, if we use ChatGPT, which is usually what everybody uses as reference, the metadata also comes at the end, so there should be something there. And we have another question here, and hey, I am going to put this one here, so please do not quote me on the crappy solution to stream everything to the user when you have it there. That was just a joke. Don't do that, or do it, but do not say Bruno told. and said that yes, it's comparison property. A little more complex like that, but that will be a nice way to start the explanation of how it works. And sorry, I saw one here about. Okay, so this is my friend. Now I know who he is. So 554 in license, Phi generate embeddings. I don't think Phi is going to generate embeddings. Phi is not an embeddings model.
I don't think so. Yes.
Rational model. I literally found here the comparison that we had before. So let me show here. So this is in the Olama. In Olama already have 5.4 to download, and this is how Phi compared to other models. So you can see here that Phi in the parameters that it's using is in 15 parameters versus big ones like Llama 3.3 or Gwen 2.5, which are in the 70s millions. And this is the average that we have in the MMLU in terms of quality. So huge loop here. I'm sorry, huge jump here from quality from the 65 to the 85, and also a lot bigger, but not as bigger as the other ones. So this is a sample, and I will say that keep an eye on Phi if you want to do it. We are using this a lot, and again, all of the models they always have new models. If I go here in Llama to the model, the populars are Llama 3.3, 5, and if I go to the newest, you always find whatever. So this is from Cohere, this is Solmo, there should be some Mistral, some model somewhere here. We can take some time and take a look at this. But hey, Phi is one to use, but Phi is not for embedding. For embeddings, as Kevin was showing, you can use locally the Nomad that we were using. We also use another one which is called, let me open my console. The ones that I use, I have Olama running in my container. And if I open, this is the model that I have locally. So this is an embedding model that I just download to have it here, to have it there. This is also an embedding model. And there should be more for sure. But take a look at this if you want to do embeddings. But Phi, this one is not for embedding. And not the same with Llama and Marco and the others. So take a look at this. Okay, so we have a question. Sorry, let me move back here to the questions. I have a response here to show, but any thoughts around what type of files are supported and more?
I do, and I would love to respond that. I don't know if kernel memory has some options for this, but there is a beautiful project that I've been exploring and playing with from Microsoft Open Source, which is called Markdown. I'm going to share the link, but can I share?
Screen? Let me show this if you want, because this is also another one. So Markdown, it's a super cool, as Jose Luis mentioned, a super cool library that basically converts, and it's somewhere here, Markdown, I have it somewhere here, converts everything to Markdown. So you can drop images, Word documents, PDF, Excels, PowerPoint, everything to Markdown. The challenge that we have in the .NET world is that it's Python only. So with Python only models, how you can use this? So the way that we can use this, and it's somewhere here, I don't know, this is a huge solution. I'm going to share it here, the link. And this is a chat with your data. This is basically a full solution. There are 20 microservices here. But one of the services that we have here is exposing an endpoint of Markdown using csnakes. Csnakes is a library that has basically, that allows you to expose Python library. And the way that it works is like this. You create a Python environment, and it's going to work in Mac, it's going to work on Windows, it's going to try to figure out where they have the. Then if you have also requirements, it's going to install the requirement. And then if in your projects you have a Python code like this, which is basically using Markdown, and you have a file and you return the Markdown, you are going to have a wrapper on top of this that you can use. So this specific web API does this. Register using SysNext, integrates this Markdown file to be allowed to have this, and then it's part of the full solution where you can add documents, it's going to generate the chunks, it's going to generate the Markdown, split the chunks, store this in Azure SSH and more. But this is one way that you can use Markdown in Windows. I know that there are other Python wrappers. It's been a long time. I haven't used Iron Python in years, literally.
I usually deploy that in a container and use it as a service.
Yes, that's the other one, and I did it somewhere here. You can have Markdown server. This is literally a container where you have Markdown with some login and they convert to MD, and you have some endpoints, and then you have a container and more. But I was trying to make everything fun enough to be used in .NET. So if you want, you can run a container like this, and then there you have an endpoint, and you can send information here and there. And the other approach will be, hey, if you want, you can have embedded here using SysNext, and it's going to be full C# code, depending on how well you want to, depending on if you want to add more Python in your code or no. But yes, Markdown is amazing. It's a really, really popular one. I will say that the main challenge that we have right now is not the package that we can use easily in .NET, but there will be some news around there if we want because I think that the people who are doing the Aspire Community Toolkit, they are going to add support to Markdown, or we ask them and they are going to see how it works and more. So
they are porting it to .NET, or?
No, not porting. Basically, do something similar to what we just said. You are going to have an Aspire solution. You are going to say, add Markdown, and it's going to create a container, and you can reference the container later in your project. That's a very easy way to explain this. It's a little more complicated. It's much more complicated, but this is what you can do. So going back to the original question, yes, I will say that Markdown is a way to go for any type of documents that you have there. By the way, this solution, the chat with your data, what it's doing, it's using Markdown to everything but images. Images, we use a GPT-4o model because OCR with images are very, very, very good with the GPT models. So you can do that. And if you go in the big leagues, you can also use Azure Document Intelligence. So we are getting to the end of the hour.
Yeah.
Thank you for SysNext. SysNext is amazing. The problem with SysNext is not the problem. My challenge with SysNext is that Aaron and Anthony, the two people that I know that are behind SysNext, are in Australia, and our time zones are literally super hard to match. But I will try to bring them here so they can talk about AI.NET and SysNext on the show. Or we can even record an event there. But yes, SysNext is amazing. Hey, end of the hour. I am going to say thanks a lot. Anything else that you want to add, Kévin, José Luis, everyone else? Take the resources. We have everything here, but anything else, Kévin, José Luis?
Thank you very much.
Yeah, as well. Thanks for having me. But, well, thanks a lot for Kévin. Also, I know that he has been polishing the code non-stop for the last days. So double thanks.
Yes, and one more time I'm going to say, take a look at this. We are going to see a lot of... it blew my mind when I read about this before holidays. I think it was at the beginning of December, something like this, because I really like when we have these new approaches to solve these problems. And hey, this is a cool one. This is a nice one. And the repo is there. Anybody feel free to take a look, submit issues, more pull requests, and more. Happy to support the community. So once again, thanks everyone for viewing. See you next one. Goodbye.
Thank you very much.
Ciao, ciao.
Ciao.